get your worksheet where you've done your work on your gas law calculations, and it's time to check over them. I decided the best thing to do is just show you the answers because there are certain problems that are happening over and over, and I wanted to share them once. And many of you, if you want to fast forward through this and just check your answers as you go, that'd be fine. But when you see you miss something wrong, stop on that problem. Number one, you see, if you did not set up your given information the way I did, you would have lost a point. Please make sure you're doing this. I did a instructional video that showed you how to write the given variables down. Next, you have Boyle's Law, because you've been given pressures and volumes. So I wanted to see that written down. Very good. And then you do some algebra, and out of your calculator comes the answer is 400 kilopascals. How did I do the algebra? I needed to isolate the variable P2 by dividing both sides by V2, canceling the V2 out. And so P1 times V1 over P2, and there's our answer. Second one, exactly the same as the first one, except instead of finding the second pressure, you're asked to find the second volume. You do algebra again. Here's your Boyle's Law. Here's the rearrangement. And that gives me V2. Atmospheres cancel out, and my answer's left in liters. The problems start when we come to number 3, and we're not using Boyle's Law anymore. This is Charles' Law. And Charles' Law is the relationship between volume and temperature, and that's the first volume in a ratio with the first temperature is equal to the second volume in a ratio with the second temperature. And many people told me it was V1 T1, and that is not what your reading showed you, and that is not what, that's why I asked that question on the discussion questions about which ones are inverse relationships and which ones are direct relationships. That was to make you get this formula right. So many of you need to stop and go back and redo your number 3 with the correct formula. With the algebra here, we have also need to be working with our temperatures this time in degrees Kelvin. If you didn't add 273 to turn your answers into Kelvin units, you need to make sure you do that. Now, let's do some algebra to isolate the variable V2. We'll multiply both sides by T2. That cancels it out on that side, and we're left with V2 is equal to V1 over T1 times T2. And the first volume was 250 milliliters. The second temperature was negative 22 degrees Celsius plus 273. And the first temperature on the bottom was positive 22 degrees Celsius plus 273. And when I punch all that into my calculator, I got 212. Actually, I got 212.7. Call it 213. Is that liters or milliliters? Those are milliliters, not liters. And that's how you would do number 3 as well as number 4. Number 4 is done exactly the same way, but number 4 is the one that was messed up, and instead of saying degrees Celsius, it said degrees Fahrenheit. That was a typo. You do not need to work ever in Fahrenheit for me. If you ever want to change Fahrenheit to Celsius and then Celsius to Kelvin, if you did that, bravo for you. Good for you. I'm not going to make you do that, and I don't even have the answer written down here on my paper all of a sudden. I'll back up and do that one at the very end. Number 5 had P1 T1, the pressure one was 965 millimeters of mercury as another pressure unit. V1 was 25 Celsius. That needs to be in Kelvin, so I add 273. P2 T2 is what I'm asking you to go find. And T2 is started with 50 plus 273, and that'll be in Kelvin. And this relationship between pressure and temperature, P1 over T1 equals P2 over T2. I'm asking you to find P2, so multiply both sides by T1. P1, multiply both sides by T2, that was, over T1 equals P2, which would be 965 times 25 plus 273, and over, whoa, that's not right. Got carried away there. My second one was 50, wasn't it? That's T2. T2 was 50. And this is T1. That's 25 plus 273. And I got 1045 millimeters of mercury as my new pressure. I love problem 6, and you probably didn't because you weren't sure what to do. We have a given pressure of 1 atmosphere because it says at sea level. I wanted you from the reading to discover something that it talked about what pressure is like in different places. You were also told that the first temperature was 21.1 degrees Celsius, so I need to add 273 to make it in Kelvin. And my first volume is not given. So your answer will be in terms of V1. There's going to be a V1 in your answer, and that's okay. You're going to say V2 is equal to something times V1. P2 is 0.72 atmospheres. How do I fish that out? Because I look for the unit of pressure. T2, I fish that out where I see degrees Celsius, 4.8. Got to make it Kelvin, 273. And V2, that's what it told you to go find. Okay, this uses the combined gas law that puts together all 3 of the ones that you learned about. P1 V1 over T1 equals P2 V2 over T2. My P1 was 1 atmosphere. My V1, I don't know. My T1, 21.1 plus 273. P2, 0.72 atmospheres. V2, what I'm trying to find. And T2, 4.8 plus 273. All right. So, doing some algebra here, I want to isolate V1. I'm sorry, I want to isolate V2. I want to find what V2 is equal to. And so that's going to be equal to 1 times V1 times 4.8 plus 273, whatever that is, and divided by 21.1 plus 273. That's my T1, that's my T2. And I also have to get rid of my pressure number 2. I'll have that on the bottom, 0.72. Why do I not just go ahead and add 4.8 to 273? That one's easy. I can do it in my head, but sometimes it's not easy, and I wait till I pick up my calculator at one time and punch all the answers into it. And so this comes out that my V2 is, how do you put V1 in your calculator? You don't. I did 1 times this divided by this divided by that sum, and when it came out to be 1.3 V1. V1's just still there. What does this mean? Volume 2 is 1.3 times bigger than V1. So that pretty much means it doesn't matter what my first volume is, it's always going to be 1.3 times bigger. So moving on to number 7, probably I should have given you number 7 before I gave you number 6, and it had you do the same combined gas law setup. And so our P1 was 2 liters, V1 was 110 kilopascals. Temperature number 2, doing the algebra, was 80 plus 273, and T1 was 30 plus 273 times P2, which was 440, and that gave me 0.58, and it initially started in liters, so my new volume is given there. Now, this was a little bit long. Sorry about that. I hope this helped you a little bit. Send me feedback, please. If I don't hear from you, I think everything's okay. I appreciate those people who are sending remind questions. I appreciate everybody that's emailing questions. It's kind of harder for me to answer when you comment on Google Classroom because I can't click my notification and get there easy, but I'll get to you, I promise. Do send me messages. Do keep in touch. Do stay safe. Do stay home. Do not get tempted and leave. Everybody, we want to go back sometime, so let's all get this over with. Here with you. Bye.